Welcome to National Astronomy Week, Life on Mars. Now, we are so pleased to have you all attending this morning. My name is Jo Fox and I am one of your hosts today. I am a space champion for ESRO UK and also a partner for Space Fund, specialising in space-themed educational shows and workshops in schools. I am also the creator of Space Teams, a new interactive website that takes you on a 2-week mission to Mars. Now, your second host is Ali Bruce. Say hello, Ali.
Good morning, all. How you doing? I'm Ali Bruce. Thanks, Joe. I'm an astronomer. Last year I was working at the Royal Observatory in Edinburgh. This year I'm now working at Dynamic Earth in Edinburgh. I'm their new planetarium manager. We have a shiny planetarium and it's mostly empty because of current restrictions. So this is about as close to Mars as I can get. And I'm just very happy to be helping out today. So thanks very much.
That's fabulous. Now we have lots of super speakers for you all today from Astrobiology OU. And if you have any questions, then please type them into the Q&A section at the bottom of your screen, and we'll do our best to answer them throughout the session. Now, it is with great pleasure I'd like to introduce our first guest, Professor Karen Olsen-Francis. Now, Karen is a professor of geomicrobiology and she works on life at the limits. She is interested in microorganisms that live in extreme environments on Earth that help our understanding of extraterrestrial locations. Hello, Karen.
Hi, Jo. How are you? Thank you. Hi, everybody. And if you didn't understand some of the terms that Jo used, don't worry about it because we're going to explain to you in the next session. So with me today, I'm not alone. I have some of my team with me. I have Mario. Mario, would you like to say hello?
Hello, can you hear me? Can you see me?
Yeah.
How are you doing? Yes, I'm a postdoc, so I am looking for life on Mars, trying to find places on Earth, but I'll talk about it a bit later.
And we have Alex as well.
Hi there. Hi, everyone. I'm also a postdoc with Karen's group. What I do is to try and recreate Mars in the laboratory. And yeah, you'll be hearing about that from me later on as well.
And we also have Hannah with us.
Hi everyone, I am here to tell you all the cool things about Mars and to get you playing a quick game later on. So we'll be having a go in a bit.
Thanks everybody. So the first question I suppose we need to ask is, what actually is astrobiology? So how many of you have actually heard of this word before? We can't really use the hands up app very easily here. So if you talk to your teachers, and how many of you actually heard of the term before? I'm sure some of you have. Well, if you don't know about it, then astrobiology, if you ever wondered about if life exists elsewhere in the solar system, well, if you've already started to think like an astrobiologist. The research area of astrobiology is driven by the question, are we alone in the universe? And as astrobiologists, we investigate if the life exists elsewhere, and if so, what evidence could be used. To do so, later on today, you'll hear from Mario and Alex that will talk about some of the experimental work that we do to look for this. But before we hear from them, we need to think about what life actually looks like. So when I ask you what life will look like elsewhere in the solar system, you could think of anything. You know, you read lots of books and they look like big aliens, little green aliens. But actually, as an astrobiologist, when we think about life, we think about microbes or bugs. And these are really tiny, tiny things that we need to look for under microscopes. Imagine you've all heard of the term microbes, or more commonly known as bugs. And on Earth, they're basically everywhere. And look, I have one of my little friends here. This is a very large example of a microbe. And because they're everywhere, that's why it's really important, you get told to wash your hands, because some microbes can make you sick. But not all microbes can make you sick. There are actually some really good microbes as well. So for example, you use yeast to make bread, and we can also use microbes in yogurt. And as astrobiologists, we're really interested in microbes that live in extreme environments. But these are these are environments where humans wouldn't be able to survive. So, for example, we think about the cold deserts of Antarctica and also the geothermic areas that we know about where volcanoes exist. And microbes that live in those environments are called extremophiles. They're like the superheroes of this microbial world. And as you can see here, my microbe has a cloak, because he's actually a superhero. And what we know about life on Earth, we use to infer if life could exist elsewhere. So when we think about life on Earth, we know it has 3 key ingredients, and I'm sure you know these yourself. It needs water, we need food, energy, something to eat, and we also need bioessential elements. And as a human, we need to have these as well. You're always told to drink plenty of water, eat lots of fresh fruit and vegetables, and have lots of vitamins. And this is the same thing if we're looking for life elsewhere. So the focus of National Astronomy Week is focusing on Mars. And as an astrobiologist, we think Mars is really exciting. Although the conditions on Mars, if you look behind me, are really, really arid and really extreme for life to exist on, millions and millions of years ago, they might not have been like this. And we believe that liquid water could live on the surface, such as lakes. And in these lakes, it could have harbored life. So there are many rovers on the surface of Mars at the moment that are looking for evidence of life. But realistically, if we were to find evidence of life on Mars, it would probably be dead. It would probably be something like this. Now, this is a biomolecule or a signature of something of life. So this is DNA. DNA is a molecule that all living organisms possess, and it holds like the blueprint of life. And to understand how these molecules would look like on instruments on the Mars surface, we need to start looking at locations on Earth to help to infer this. And you may wonder, well, why do we use environments on Earth? They're not similar at all to what we'd expect. Hannah, I'm going to hand it over to you to try and have this conversation about life in extreme environments and comparing them to extraterrestrial.
Great. Thank you, Karen. That's a really great introduction to what we're going to be talking about next. So I've got a quick game for us to play, and we're going to be looking at the similarities between Earth and Mars. So what we're going to try is, you are going to see some pictures in a second. I'm going to get the first one up. And what I would like you to do is, you can have a discussion in the rooms that you're in, and that's the wrong one, isn't it? In the rooms that you're in, and see if you can work out if my pictures are of Earth or of Mars. So we're just going to try and share the first screen. There we are. So here we go. So we're going to have Earth or Mars. So if you think it's Mars, what I'd like you to do is try and use the hand up function in Teams, and see if you can, in Zoom, and see if you can tell me if it's Mars. And if it's not, keep your hand down and you think it's Earth. So hands up for Mars and down for Earth. If you can't get to the hands up function in Zoom, don't worry, you can do this in your classroom. You see who thinks what is what. So I can see a lot of people trying it out now, which is great. So we're going to get to our first image. We're going to see what we think it is. So here we go. Here's our first image. So you need to put your hand up if you think this is Mars, and keep your hands down if you think this is Earth.
Hannah, you might want to change that display setting.
Which one have we got? Are you seeing the wrong screen?
Yeah, you have it in presentation mode.
How's that?
Better, perfect.
Aha, so that means you may have already got a hint of what's coming then. So we'll go past this one if you've already seen what's coming next. So this one is indeed Mars. Here it is. So this is a photo and an image of what's really on Mars. Okay, so we've had a little try and you've had a little preview. So we're going to see how we do with the second one. So here's another image. So we're going to put our hands up if we think this is somewhere on Mars, and keep our hands down if we think this is somewhere on Earth. Give us all a few seconds just to make a decision. See how we're going on. I'm not seeing many hands, so let's have a little look. This one is actually on Earth. So this is a drainage basin in South Yemen. So it looks fairly similar to what we might be thinking might be there, but actually it's on Earth. So here's another one. So if we put all our hands down to start with, and here's our next picture. So what we're going to be doing is hands up again for Mars and hands down for Earth. having a little look at this picture, where do we think this one might be? Going to give you a quick moment to make a decision and to quickly vote. Let's see what's going. Brilliant. Okay, so let's find out who's right. This one then is Earth again. So similar to what we might be thinking we could find on Mars, but actually no, this one is here on Earth, and this is the Colorado River Basin. So this is it during a drought, which is why it might look a little similar, but this one is here on Earth. Okay, next picture here. So, right, and again, hands up if you think this one is Mars, and keep your hands down if you think this one is Earth. I think some of these are always very difficult. Going to give you a few more moments, see how we're doing. And seeing lots of things changing. This one is Mars. So it looks like it could be a hill here on Earth, but actually this one is Mars, and this is Columbia Hills. And so it looks fairly similar to what we might be seeing here on Earth, but is not. I think we've got a couple more. So let's try this one. So hands up if you think this one is Mars. So looking very closely, seeing if you can work out what it is. Hands up for Mars, keep your hands down for Earth. Just going to give you a few more seconds. I can see things changing, people making their minds up. Oh, couple of people changing their minds quite quickly. Right, this one is here on Earth. This is the Namibian desert. So lots of rocks, but looks quite dry. And it's what we think we might be seeing on Mars, but again, it's another odd one. So here we go. I'll go for one more. I think this is my final one. So this is our final one. So again, hands up if you think this is Mars. Keep your hands down if you think it's Earth. See how we're getting on. Got final few seconds just to make your decision. Few things are changing, few things are going on. Brilliant. So this one is actually Mars. This is Gale Crater. So you can see some mountains in the background, some hills, but actually this is not here. And this is why looking at Earth to look at Mars is really important, because some of those environments are really, really similar and look the same, and there's some things about them that are the same. So I'm going to hand over to Mario, and he's going to explain how we can look at environments here on Earth that are very similar to those in Mars, and how that can help us in the search for life.
Well, Hannah, thank you so much for that introduction. This is great. So now it should be very easy to just start my part. So yeah, as Hannah has said, I am looking at places on Earth, but places on Earth that look like Mars. And I guess that the first thing that we need to think is, what is the most different thing between Earth and Mars? And I would say that that is the atmosphere, so the air surrounding life or everything around us. So on Earth, the air around us is basically made of two gases, it's nitrogen and oxygen, and then a full array of other different gases. One of them is methane. But the atmosphere on Mars is completely different. It's basically made of carbon dioxide with a bit of nitrogen, with a bit of argon and other minor gases. And the thing about this is, if we think about us as living organisms, we couldn't survive on Mars because we don't have oxygen, which is what we need to breathe. But interestingly, there are plenty of bugs or microbes on Earth that actually can use all the gases. So let's see how they do this. So if we think of us as humans, if we all take now a deep breath, what we are doing is getting oxygen into our lungs, and then when we exhale, what we release is carbon dioxide. But as I said, there are some microbes that don't need that oxygen to breathe. So, for example, we have this green microbe here that is going to use something very different, and it's going to produce a different gas to carbon dioxide, which is methane. And why is methane very interesting for us? Well, thing is, on Earth, 90% of all the methane around us is produced by microbes. So that means if we have found methane elsewhere in the universe, there is a chance that it must be produced by microbes. And actually, there are satellites around Mars, and we also have robots that are called rovers on Mars that have found this gas. So if you remember, Hannah has mentioned Gale crater, and she's mentioned similar places that we can find on Earth. But this is the same picture that Hannah showed about Gale crater. So we can see this kind of very compact soil that is made of crusts. That means that in the past, Gale crater had water, and that water at some point just disappeared. So maybe Gale crater that nowadays look like this, in the past, it looked like this. And what would be very interesting for us, if we can find any place on Earth that is similar to this. And the question is, are there any places like this on Earth? Yes. So let me show you. This is Basque Lake in Canada, and is very rich in salts, the same kind of salts that we found on Mars. So the next question is, are there any microbes living there? So what I do as a astrobiologist is just going there and getting samples of soil, of what it looks like, microbes, that try to grow them in the lab. And actually, this picture here on top right-hand side is what we call a biological mat. So this is not soil. This is just like a blanket made of microbes. And it is so thick that if the microbes are producing any gases, the gases can't escape. And this is why we have these bubbles here. These bubbles are gases produced by microbes. So one of the things that I do on my research is actually analyzing those bubbles and see what gases have been produced. I'm trying to find if there is methane. And actually, surprise, there is methane. So we have a place that looks like Mars and is producing a gas that is biological. So the next thing to do is trying to grow these microbes in the lab and making like a Mars-like soup. So in this point, I'm not going to talk anymore, and I'm going to just hand it to Alex. So Alex, take it away.
Awesome. Thank you very much. Let's just...
let me get the share.
Awesome. And there we go. That should be working now, I think, hopefully. Yes, so thank you very much, Mario. And from talking about places on Mars, places on Earth that look a bit like Mars, I'm going to be talking about how we can actually recreate the conditions on Mars in the laboratory on Earth. So I'm going to be talking about making planets in bottles, or making a Martian soup today. So, as we said before, we send missions to Mars and they tell us what kind of rocks and what kind of chemicals we find at the surface there. And then what we can do is we bring that information back, and then we can recreate those conditions using the same chemicals and different things on Earth. Kind of like making a Martian soup. So turning the red planet into a kind of soup. Now, when you're thinking about making a soup at home, what is the first thing that you need? You need your ingredients, right? And this is what it might look like. You might have tomatoes, potatoes, garlic, stuff like that. But instead of these kind of ingredients, what we use in the lab looks more like this kind of chemicals. And the second thing you need is a recipe. So how do you actually make that soup from the ingredients? And it's a bit like what you would do with a regular soup. So what I do is mix all of those ingredients up in the lab using this, this cool little piece of kit here. And you can see that there's tubes going into it. So Mario talked about the Martian atmosphere, which doesn't have a lot of oxygen in. So what we do is we recreate that Martian atmosphere with no oxygen in it for these microbes as well, for making these soups. So you mix all these ingredients together and then you cook it. And we cook this at about 121 degrees Celsius to make sure that there's no contamination, there's no microbes getting in by accident. And what comes out the other end are these really cool, nice looking colored soups. And these represent different places on Mars. So these are actually based on different real places on the Martian surface. And you can see that they're very different just by the color, at least, and that's because of the different chemicals inside them. So we have our Martian soup, and the next thing to do is to add life into the mix. So we choose microbes, quite often the ones in these environments Mario was talking about, these analog environments, that we think could actually live quite nicely in these Martian soups. We add them in to these little bottles of the Martian soup, and then we find out which ones they like and which ones they don't like. The way we do that is to count them. So we look down the microscope and we see these bright little green microbes, these bugs, and we can count them to see whether or not they're increasing in number or decreasing in number. And that tells us whether or not they like these soups. We can also measure how much food is gone using cool pieces of kit like this that tell us how much they've eaten. And we can also see what comes out the other end. So we can do different experiments to find out how much stuff they're actually producing from the food that they've eaten in those soups as well. So really, this is what we do overall. We look at Mars, we take all the information from Mars back, we recreate it in the lab, we put life in there, and we find out whether or not it likes those Martian environments. And from that, we can tell whether this kind of life might have lived on Mars today or might have been able to live on Mars in the past as well. Thank you very much. And I think we're going to take questions, so I'll stop sharing at that point.
Okie dokie, thank you very much, everybody. That was awesome. I am now definitely having soup for my lunch now as well. I don't know if anyone else has been, the seed has been planted. So yeah, we do have a few questions. I'm just going to fire away. We do have a few minutes, which is awesome. So I'm going to throw two out and you can decide who gets to answer them, I suppose, because it's nice we've got so many people. We definitely have time to answer nearly every question in the chat. So the first question is from Kate. Why is Mars red? And I'll throw out the second one at the same time from Mrs. Bond. Is Mars the same size as Earth? So I don't know, maybe Hannah for the Mars is red thing would make sense, but feel free to jump in.
Oh, these are brilliant questions. Now, I think actually the best person to answer these might be Mario or Karen, possibly. I'm going to hand it off to one of them. If one of them is willing to unmute and come back on, that'd be great. I reckon they've probably got an answer to one of these.
Right. So I'm going to jump in. So if the reason why Mars is so red is because it's covered in iron. So it's basically covered in rust. So the amount of iron that has been deposited on the surface of Mars gives this very nice orangey reddish color. The reason why this is happening is because we can see the light reflecting on the surface of the red planet. The other question was size. Mars is smaller than Earth. I can't remember how much smaller, but I know it's smaller. Alex or Karen can remember how big is Mars compared to Earth?
I think it's about 1/3 of the size, I think.
Okay, fantastic. I think it might be about 1/10 of the mass. I seem to remember that from my homework back in the day as well. So next question from Priory Class St. Mary's Primary. It's a good question, this, so maybe, I don't know if Karen wants to take this one or anyone, again, feel free to jump in. What actually qualifies as alien life? Good question.
That's a really good question, and I think the debate is out on that. For us as astrobiologists / microbiologists, it has to have, key ingredients. It needs, it needs to be able to grow and divide and to be life, for it to be living. But then also, we look at life as we do on Earth. So we're looking at just life on Earth, very basic. If it can multiply, and if it can divide, are kind of the main things that we define as life. But we look at it like a carbon life, nothing too flash.
Okay, fantastic, thank you. And then from Sai, another deep question. Have we ever been close to finding life on Mars?
Who wants to answer that one? I think, should we go for Mario?
Can you repeat the question, please? Have we ever
been close to finding life on Mars? And I guess you could almost rephrase that. Are you confident we might find signs? So it's up to you.
I mean, I think that in this case, a bit of wishful thinking. I would love to be able to find life on Mars as an astrobiologist, but I don't think that we are close to find it per se, because we don't know if it's there. We don't know where it is quite just yet. We have some places that we think that could be candidates because they look a bit better for life to be there. but I don't know how close we are, or even if we are close to it quite yet.
Can I add to that though? But we have a number of really exciting missions that are going to Mars in the near future, and hopefully with the instruments that we'll have on Mars, then we'll be able to have some ideas to kind of piece together the jigsaw. So it's very much a watch this space, and hopefully in the near future we'll be able to we'll be a step closer to answering that question.
Awesome. And I think, yeah, you're going to definitely hear about one of those missions in a little while as well, which is great. Another question here from Caroline. Why is Mars so dry?
I think maybe I'll take that one, if that's all right. So one of the reasons for that is because of the atmosphere that Mario mentioned as well. So one thing that happened quite early in Mars's history is it lost most of its atmosphere to space, partially because it's a lot smaller than Earth. And once you don't have a very dense atmosphere, then all of the liquid water can quite quickly evaporate into space. So a lot of the liquid water actually just evaporated off Mars quite early in its history, leaving it quite dry today.
So I guess there's a follow on here from Starfish class. Does Mars still have water on it today?
You go, Alex.
Yeah, yes, Mars does have water on it today. We know that. So there's not as much liquid water, but there's a lot of water trapped as ice on Mars. So Mars has polar ice caps that are mostly water. And there's also hints that there might still be liquid water on Mars today, with very salty water underneath those ice caps, but also potentially some really salty water at the equator as well, that comes out sort of in summertime when the temperatures get up a little bit, but not very much liquid water.
Cool. Question here from the Muller family. Why are you looking for life on Mars? Why not on other planets? Fine question.
Well, we are looking on Mars because but we're also looking at the icy moons as well. So we're not putting all our eggs in one basket, as they say. I think, looking at Mars, it's an easy planet to get to. It only takes about 6 months. It's really easy. And there's evidence there was liquid water, for what Alex and Mario said. So it's a really good target for what we're looking at, particularly for extent life. But again, there are other environments that we are looking at, and there'll be a few missions you'll hear about in the next couple of years looking at the icy moons. And I'm sure we'll probably be doing an event like this very similar when those emissions happen as well.
Fabby. And last question, I think that's all we've got time for. So we just from S. Blythe, have we explored the whole of Mars? A lot to unpack there.
I don't think that we have explored Mars, and we have plenty of Mars to explore. I mean, not even the surface, but even what is a bit under Mars, there is a whole new world to explore. So again, as Karen has said, this is a matter of just stay tuned and see when we send more missions to see what else we can see around.
That's awesome. Thank you so much, everybody. We do have loads of questions, so it's fantastic. So feel free to keep them coming. We have everybody's going to be on the call for a little bit longer, so we can try and answer as many as we can in the chat. So if I didn't get to your question, I do apologize. We're now getting ready to hand over to our second speaker for today. So if Dr. Sandra Voss, if you can switch on your video and join us. Sandra studied for a PhD at the Royal Veterinary College, became a lecturer in the Department of Animal Husbandry, and then after travels around the world, Sandra found herself in East Sussex at, I'm going to pronounce this wrong, Herstmonceux at the Observatory Science Centre. So originally you would have started as a volunteer there. In 2003, you actually became the coordinator for National Astronomy Week. So your association with the NAW goes back away, which is awesome. And since that time, you have now gone from being a volunteer to the bona fide science director of the Observatory Science Centre. So Sandra, the virtual floor is now yours, and we'll see you after.
Hi. Hello, everybody. Nice to be here. Those were fascinating talks. As Karen said, you're looking for astrobiologists, looking for microbes, really. Brilliant. And these microbes could produce gases. Love Alex's experiments. And I'm going to show you now not such sophisticated experiments, but experiments that you could potentially try out in the classroom. So if somebody can share my first, I've had to pre-record this. That's the one.
This is a simple experiment to find out if we can look for life, or how difficult it is to look for life, not just on other planets, but on Earth as well. So what we've got are 3 beakers. I've sort of simulated Martian soil. It's not really Martian soil, but we've got some red sand in there. Now, just by looking at it, we've actually put the same amount in each beaker, so to make it a fair test. And we've labelled A, B and C. Can you see any life? I can't see any life in any of them. Can you smell it? Is there any difference in the smell? I can't tell any difference in the smell. Maybe we need to take a further look by using this magnifying glass. To have a look further with the magnifying glass, I'm going to take just a little bit out of each jar. I'm going to put them by there. Now I'm going to use a different spoon for each one, because when we do experiments, whatever experiments you do, you don't want to contaminate one with the other. We call it cross-contamination. So we're going to just take a little tiny sample. Now, when rovers are on Mars, they do take tiny samples of the Martian soil. They don't probably have a magnifying glass, but they have other things. I'm going to have a really good look. They all look the same to me. So, there are ways in which we can try and do further experiments to find out potentially if there is life in these jars. Potentially. We know how difficult it is to define what life is. Scientists all over the place still can't agree completely on an absolute definition of what life is yet. Well, scientists can't exactly work out exact definition of what life is. They sort of agree that life uses energy, it grows and it reproduces. What do we need for energy? We eat food, don't we? So what we're going to do with this experiment, we're going to give some sugar. Energy, sugar, yum, yum, yum. So we're going to put the same amount of sugar into each beaker. Fair test. There we go. Could give it a bit of a stir. Let's just stir it in there a bit. Remember, don't cross-contaminate. Stir it in there. A little bit more. There we go. Oh. So we've given our beakers some food. What's happening? Nothing. I can't see any life. I've given it food. There must not be life in there. Surely. Nope, nothing happening. So on Earth, we know that life requires energy, and for us, humans, we need to take in some food. But all life we know on Earth uses water as well. And I've got 3 beakers of water. They've all got the same amount of water in. And I'm going to put this, it's warm water, it's just warm water from the tap. Now let's see what happens. I'm going to put A, and it just covers the sand. B. Oh, 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 oh. And C. Oh. Oh. Well, that had 1 or 2 bubbles, but nothing really, nothing in there. This one is really fizzing away. Could there be life in this beaker? In this beaker, there's not an awful lot happening at the moment. So I think we have to be patient. I think we need to give it a little bit of time and come back to it later. As scientists, we've got to be patient. So it's been a little while. It's been about 5 minutes, 5 to 10 minutes, but we've got a reaction. Look at this. Now, right from the word go, you may have noticed that this one had a little bit of a different colour. Now remember, right at the beginning, we had a look at it and we smelt them. We didn't taste them. You wouldn't want to do that. So, the same smell. Same smell? Ooh, that has got a really weird smell to it. And if you've noticed, the colour is different too. Looking at the results then, number one, it had a bit of a bubble and then it didn't do anything at all. Nothing in there really, is there? Nothing. Did you notice that in beaker B, there was a lot of fizz? So there's definitely something in there. Is it life? Beaker C, look at that. It's really bubbling. And it's continuing to bubble too. Oh, we got something a bit different. Is there anything we can do to test again, perhaps? Let's have a think about it. When you're hungry, what do? You have more food, don't you? Shall we give it some more food? Let's give it some more food. We'll give each beaker some more sugar. Not going to stir it this time. Oh, like that. We give it a little bit more water. We'll just give about half as much water as we did before. Nothing in that one. This one, we thought there was something in it, didn't we? Let's have a try. Not really, there's no reaction there at all. So whatever was in there, the reaction is completely finished. It's probably just a chemical reaction and probably not life. This one, look, a bit more water. And it is continuing to bubble. And we've got bubbles and it just is continuing. So there must be something in this particular sample that is keeping on growing, and it's actually excreting something in the form of bubbles. I wonder what that is. So do you think I put something in those beakers to begin with? Yes, I did. I didn't actually put anything in A, so there's nothing in there apart from the sand that we had, the sugar and the water. There's no life in there to take in the energy and excrete anything. It's not growing and it's not doing anything and continuing to do anything. In here, what I put in there was an Alka-Seltzer tablet. Now, an Alka-Seltzer tablet, you use that if you've got a bad tummy and you want to get rid of some gas. So with water and Alka-Seltzer, it will give off this carbon dioxide gas and then you feel a lot better. But that's it. It's not continuing. It's not life in that beaker. What's in here? Can we see that it's still bubbling? It is still bubbling a bit. Can you see? Oh, yes, if I give it a little bit of a swirl, and that smell, and you can see that it's got lots of bubbles on the top. Can you see that? Can you see in there too, with all those bubbles? It's continuing. What did I put in there? Have you heard of this stuff? Yeast. And the yeast, we use it in bread baking, but in a form that we use is dried. It's a little microorganism and it's classified as a fungus. It's a living thing and we've woken it up. And that's what you do when you're baking bread. You wake the yeast up and you wake it likes sugar. It has to have that energy and it also likes the warm water. It's a bit cold in here today, so it took a little bit of time to get going. But look, it's still continuing. And that is one of the things that we could potentially look for. It's not definitely that we can definitely find life like that on other planets, but it is a way of searching for life on other planets.
Hi, me back again. So that was just a simple experiment that you can try potentially in the classroom as well. And it just shows you that life can continue. It gives something off as well. So and you can do all sorts of different things with that. It's not something that a rover could really do on its own, but the rovers that are going to Mars are going to do some experiments, and they've just had the go-ahead as well for the Perseverance rover to actually send samples back to Earth, where we can actually do more experiments on Earth for looking for life on Mars. But I wanted to introduce you to a rover that is going up to Mars in 2022, and it's the Rosalind Franklin rover. So if I could have the next video, please, just introduce Rosalind Franklin.
Let me introduce you to the Rosalind Franklin rover. She's going to go up on the ExoMars spacecraft in 2022. She's rather sweet, isn't she? She doesn't look exactly like this. She's got 6 of these large wheels, but we haven't got these on this model. And this mast actually is a lot taller. In fact, it will stand 2 meters above the surface of Mars when she's roving on it. She's 1.5 meters long and 1.2 meters wide and weighs 300 kilograms. So why is Rosalind Franklin important for looking for life on Mars? Well, first of all, let's think about who Rosalind Franklin was. She was a chemist and she was instrumental. That means she's really, really important in the discovery of DNA and RNA, the stuff inside us that carries our genetic information, really important to life for us on Earth. So it's fitting that a rover on Mars that's looking for the signs of life or the potential signs of life was named after Rosalind Franklin. So how is she going to try and find evidence that there is potential life on Mars? Well, she's got a drill here. You might be able to see it. Can you see it underneath here? This drill is going to be the important bit. That's going to be able to drill down into the surface of Mars by 2 meters and produce a sample that's 1 centimeter wide and 3 centimeters long. Now that's important because of where they're actually going to land Rosalind Franklin. And they're going to land in Jezero crater. And this is where they think there was an awful lot of surface water on Mars in the past, when Mars could have been potentially habitable and had lots of water on its surface. So the 2 meters, it will get down to a place where there is potential organic matter, organic molecules. The stuff is like the building blocks of life that we know on Earth. So they're going to try and find it. So they're going to drill down, they're going to get this sample, and then inside Rosalind Franklin, it has a laboratory. Wow, pretty cool, isn't it? So what they're going to do, they're going to bring that sample up and they're going to grind it into fine dust. And then they're going to put it under a microscope, have a good look at it. You know, we did that experiment and we did actually look through a magnifying glass. So they're going to have a look at it and then they're going to analyse the soil sample with 2 different other instruments as well. And I'm going to try and look for these organic molecules and minerals as well. And I'm going to try and identify them and see what they can find. The ExoMars project is pretty important to the UK as well, because Rosalind Franklin has been built in Stevenage in Hertfordshire, which is pretty close to home really. So we're very, very excited by this being a European mission and bringing back potential signs that Mars either had life on it or maybe still has life, microbial life, so very microscopic, you can't necessarily see it with your unaided eye, but it's very, very exciting times.
And there we have it. And that's the end of my presentation. Thank you very much for listening.
So there's a couple of questions about the Martian atmosphere as well. So you just in terms of getting the probes to Mars, there was a question about how you actually get the vehicles onto the surface in the first place. Is it easy or is it difficult?
I'm not an expert on this by any stretch of the imagination, but it's difficult. I think, you know, it's like landing something. You're looking at something far, far away and having to land on this sort of like tiny little bit of place where you hope there's no boulders or anything like that. And then you've got to sort of land it really carefully, whether you land it with a parachute or what have you. So no, it's difficult. It's not an easy job, not an easy job at all.
From T4 Nelson Primary School, does the Rosalind Franklin control itself or is it controlled from Earth? That's a good question.
That's a very good question. It's actually got to control itself more or less, because it's got to be quite autonomous, because of the signalling back from Earth up to the orbiter that's taking the signals, and that orbiter only goes past where Rosalind Franklin will be for a couple of times a day. So it wouldn't do very well if it had these signals coming just a couple of times a day. It takes a long time for the signals to get there as well. So yeah, it's got to do it itself.
I have a question. This is from Beatrice, and she is asking, how is the Rosalind Franklin going to reach Mars?
It's going up on a spacecraft, so it'll go up by rocket and then actually be deployed onto the surface via it's a mission with ESA and Roscosmos as well. So they'll be landing this. So you still have to get up there and in a rocket.
Nice question from Rachel here. Will it be possible for humans to live on Mars in the future?
No expert. Anybody else jumping in from the Open University will be helpful here. And they want to go, don't they? I don't know. Not in my lifetime. That's my answer. Anybody else?
That's maybe the follow-up question is would you want to go if they offered you a rocket trip and it was going to take you 3 years to come home? Would you say okay? No.
No, thank you. It's the sitting on top of a rocket that worries me more than anything else. I don't know the fact that you can't come home. No, I wouldn't want to go. Sorry.
I have a question from Ben. He wants to know why is the top of Mars white?
It's the polar caps, isn't it? It's the like Earth. Earth is tilted, and this is the reason why we get seasons. And Mars is also tilted, not by quite so much, but that means we do get seasons. And so when it's really, really white on the top, they're in their winter time, and when it's not quite so white, they're in their summertime. So that's the reason why it's polar caps like we have on Earth as well.
I was to say, it's a question from Miss Stone. Would you be able to grow fruit and vegetables on Mars?
I don't know. I think I might have to pass that one over to the people that know more about the surface of Mars. Anybody else come in to answer that one?
I think I can answer that one. So there is quite a lot of controversy. So there are very different ideas about this. Some people say that it might be possible, but it's going to be depending on what part of Mars you are, because there are certain salts on Mars that are called petrolates that can be very toxic for life. But if you can find a part of Mars that doesn't have this kind of salt, and you're able to like add some microbes and add some organic material into the Martian soil with air commas, then you might be able to grow veg on Mars. And actually, there was last year some people that actually made this simulant, so very similar soil to how the soil on Mars looks like, and they were able to grow some tomatoes.
So I guess the other question was, how does the Rosalind Franklin rover actually pick up the sample after it's drilled? I don't actually know the answer to that, so I'm curious if. I'm sure I've seen a video of it. I think after it drills, does it not? It tilts it back into the sample boxes and then does the analysis. But yeah, I would need to make sure that's still correct.
As far as I know, the drill actually collects it as it drills down. So it's a special drill that can actually bring stuff up, you know, a bit like when they're drilling in the ground to, you know, drill for oil.
So one from St. Martin's School here. What does the rover analyse, and how long does it take for the information to get to Earth?
Well, it's analysing the actual soil samples. They're looking at it's spectrometry, isn't it? Anybody else from the OU can tell me different from that. So I don't know how they're getting there. I know the trace gas orbiter is the link, isn't it? So I don't know how long the results take to get back, or how they're actually doing that. I haven't really looked into that a great deal.
So this one's definitely not a sample return, is it? That's still something that is going to be coming down the road. So we're not sending bits of rock back to us.
So there's a whole
Perseverances.
Yeah, so Rosalind Franklin is a whole suite of instruments. So it's not just one type of instrument. So the idea is, if you want to find evidence of life, you need to use lots of different methods. So it's not just, I know it is spectrometry, but you've got a whole load of instruments that we use on Earth to detect life. So it's kind of a bit of everything in there. So that's how it works. And then the next mission, Perseverance, is Mars sample return, where they'll be collecting these little tubes and leaving on the surface. And then in 2028 or 2029, we'll hopefully go back, pick them up and bring them back to Earth.
Okay, I have quite an interesting question from the Muller family. How much of Mars can you see from Earth?
It's a fine question. You can technically see almost all of it if you're just patient, but there's a few issues there because obviously the Earth has quite an annoyingly thick atmosphere. So if you had a telescope pointed at Mars, and for those of you who are keen, we'll hopefully be doing some live Mars observing in some of the evening sessions. It wobbles about a lot, but if you're careful and you can use videos and you film the whole thing, you can slowly stack your images together and build up the whole picture. And because as Sandra was saying, Mars is tilted, so you do get a chance to see the whole planet. It's difficult though, so this is one of the main reasons we want to send probes out to these places. In terms of sending the information back, it only takes something like a minimum of 5 minutes for the radio signals to get to and from Earth and Mars. That's still quite a long time. If you were on a phone call and you had to wait 10 minutes for somebody to say, "I'm fine, thanks," it can be a long time. So if you had humans out there, it's a big delay. But if you wanted to actually travel there, it takes you a minimum of about 4 to 6 months to actually get there. So that's why this is all such hard work, but it's very exciting when we do send new things towards Mars. So I can't wait. I've just realised I haven't been clicking done on some of the questions, so they'll be coming back into the channel quite fast. Sorry, carry on, Jo.
I just want to add that some of you may not know that you can actually see Mars for yourselves at the moment. If you go out in the evening when it's dark, and hopefully when it's clear of clouds, and you look for a what looks like a very bright star which has a slight orangey tinge to it. At the moment, Mars is very close, so you should be able to see it. I've been out looking at it whenever I can because it's really beautiful. So do get outside and look up.
There's a handy piece of software called Stellarium, so it's free to download and use, and I think you can get it on your phone too. So if you're curious as to which dot is Mars, if you're struggling to figure out where it is on the sky, that'll be able to tell you. And yeah, you want to make the most of it while we're still close to it, because we're going to run away in our orbit quite soon, and Mars will be too close to the sun to see.
Okay, well, thank you so much, everybody, for all your wonderful questions. We've only got a few minutes left, so I'd just like to say a really big thank you to all our guests from Astrobiology AU and to Alistair as well. That was so interesting. You know, I've certainly learned a lot about space, and I hope you all have too. And that's one of the really wonderful things about learning about space, is that it's constantly changing and we're constantly learning new and really exciting things about space. And that's one of the reasons why we're sending these missions to places like Mars, to find out more and more information. Also, if any of you would like to reproduce that wonderful experiment Sandra did, then if you go onto the ISRO website and you search for, is there anything out there, then you will be able to reproduce that brilliant experiment. I also would like to tell you a little bit about what's happening tonight. So we've got another session between 6 and 8 p.m. tonight. And there's going to be lots of really interesting stuff on life on Mars. We've got Martin Griffiths and Charles Cockle talking. They're going to be looking at ancient oceans and water on Mars. Plus, what's going to be really amazing, an observation session. So don't worry if you've got clouds and you can't go outside, you can actually come back here and watch some astronomers around the world looking at the sky. It's really brilliant. I thoroughly recommend it. And then tomorrow, we've got another session, a bit like this one, with some other speakers, one of which will be me. And that's all about Mars and Earth, looking at the comparisons and the similarities between these wonderful planets. Well, I think it's time for everyone to say goodbye. So if you can, are we all on camera at the moment? Is everyone on camera? Should we give everybody a big wave?
Goodbye. Thank you, everyone. Everyone say goodbye.
Thanks all.
Bye.